for day 3 today, we are going to be doing composite figures. It's where we've stuck a bunch of junk together. And so I don't have a formula for this weird pointy house that fell over shape. And so in order to find its surface area and volume, I need to figure out, okay, what can I break it into that's less scary? So what can I break that into that's doable with the formulas we got? A pyramid and a cube. Okay? And I'm just going to tell you right off the bat, volumes are almost always going to be simpler. Okay? So we're going to be doing surface areas and we're going to be doing volumes. Oh, actually, I'm going to do volume in a different color so I can keep crap straight. Okay, so here's volume. All right. Now, if we're going to break it up into smaller shapes to figure out, what you want to do is plan before you start what shapes you're doing. So my surface area here is going to include what shapes?
Triangle.
Now, could you do it one piece at a time and do a triangle, a triangle, a triangle, a triangle, a rectangle? Could you do that?
Yeah.
You literally could. Don't recommend it. I recommend the shortcuts. What is this shape here?
Cube.
Wrong.
Oh, wait.
It's a prism. And you could either say it's a rectangular prism by making this be the base, or you could say it's a square prism. Now, since you have to find area of base anyway, look over at your pyramid. What's the base of your pyramid? It's the square. So if I'm going to use that as the base of my pyramid, why don't I use that as the base for my prism as well? Then I only have to find area of base once. Okay? So I'm going to be finding the surface area of the prism. Oh, wait a second. If I'm finding surface area, doesn't it have to be the surfaces that are showing? And if this is your shape, is every surface on that prism on the surface anymore? They're not, because isn't the pyramid covering up one of the surfaces? Okay? For some people, thinking in 3D can be very hard to conceptualize. And so this may be a challenge for some people. But this top face of this pyramid is covered up by a prism is covered up by a pyramid. So I'm doing the whole surface area of my prism, except am I doing both bases? No. One base is covered up. Okay? So I'm going to do the surface area of my prism, but only with one base. What else is part of the surface area of this shape? How about this green pyramid? Is that part of my shape? Now, is its entire, are all of its faces on the surface? Are all the triangles on the surface? Yeah, all the triangles on the surface. What isn't showing anymore? The base isn't anymore, because it's covered up by a prism. So when I do the surface area of the pyramid, I'm going to do it with no base. Could you just put the whole thing and then subtract at the end? Well, yeah, if you feel like it. That's honestly how the answer key is. Because a lot of times she does the full surface areas and then subtracts them at the end. I hate that because I always forget to subtract. So I just plan up front, I'm just not going to use those surfaces. So this one then, now I'm going to break it down into pieces. Okay? To get the surface area of a prism with one base, what will the formula look like? Will it look like 2b plus pH? No, it'll look like one base plus perimeter times height. And then over here for the pyramid, what will the surface of an area of a pyramid without the base? What will that formula look like? It'll be the 1/2 PL But we're not going to do the base because it's buried now inside this goofy looking shape. See, it's hidden in there. Okay. So now you get to start tackling this one bite at a time. Okay, let's start with the big B. The big B is my base. What shape is my base? It's a square. So you're, okay, how do I get the area of a square?
Size square.
Right, which will be 3 squared, which will be? 9. Then I'm going to need perimeter of my base. Okay? How do I get perimeter? Add up all the sides, so 3, 3, 3, and 3 gives me 12. And then I need height. Which H is the height here? The height of the prism. What is the height of the prism? It's going to equal 8. Okay? So now I have all the things that go in here. This is 9. The perimeter is 12. The height is 8. But is that my entire surface area? No. Now I have to do the 1/2 perimeter slant height. Do I know the perimeter of the base of this pyramid now? Yeah, it happens to be the same as it was for my prism. So I can use that same number, 12. Do I know the slant height here?
It's 5.
Yeah, they conveniently gave that to me. It's 5, so I can drop that in there. Have I now done everything for my surface area?
Yes.
Now you can go in and start simplifying it. Okay, I'm going to have 9 plus, what's the 12 times 8? 96. And then here, half of 12?
6.
Times 5?
30.
30. So my surface area will be 30 plus 96, that's 126 plus 9 is 135. And you'd be so close!
But you need a picture.
But you need units. I am finding area, so it'll be inches squared. And that would be your surface area. Now, it took a little bit of time, but did having it color-coded and labeled to death help a little bit? Okay. Guess what? You're not done. Now we got to do volume. So let's plan out our volumes. Now, volumes are simpler because when I cut it up, do the volumes of any of them change? No. It's not like surface area where new surfaces are exposed or surfaces are disappearing. It's just cut it up. So chop it into chunks. How am I going to get the volume of this whole thing? The prism formula. So I'll need the surface area of a prism, and then I'll need the surface area of a, not surface area, oh my gosh. You guys, we're supposed to catch me. What am I finding here? Volume of the prism and volume of the pyramid. Good Lord, Mrs. Cerna. The math gods are frowning. So, how do I get volume of a prism?
It's
Area base times height. What about the volume of a pyramid?
1/3.
1/3. Area of base times height. Do I know my big B?
Yes.
Yes, we already found that. Do I know my height
Yes.
of my prism? Yes, that's 8. But watch out. Now I'm going to do the pyramid. I need 1/3. Do I know the base of my pyramid? Yes. Do I know the height of my pyramid?
You do not.
No.
I do not. It's got to go from the apex down to the center here of that base. And they conveniently didn't tell that to me. So guess what you get to do? You get to figure it out. Pythagorean theorem is probably going to be your friend here. I know the hypotenuse is 5. That's that slant height they give me. Do I know this apothem distance on the square?
No.
Well, if it's a square coming from the middle to the edge,
That would be,
it'd be half the side,
yeah, which makes it one.
which make it be 1.5. So now I can do the Pythagorean theorem here and go 1.5 squared plus my height squared is going to equal my 5 squared. Okay? And so 1.5 is what? 2.25, I think? Plus your h squared equals 25. And so my height squared is going to equal, what, 22.75? But that's h squared. Do I want h squared? No. So you got to square root it. And somebody tell me what your height approximately comes out to be, because I do not have a calculator.
4.8.
4.7 something? 4.77. Could you just do 4.8?
Yes.
Yes. Depending on which one you use, is this where we're going to get rounding differences? Yes. That's okay. Okay? If you're within spitting distance and I can tell that it's just because you round it differently, we're fine. So now I have my height of my pyramid is 4.7. What am I going to do with that?
You're going to now put that into,
I'm going to come put it over here into my formula where the h was. Don't just do the thing, write it down. Put it in context. That way you don't have to go, well, now what do I do with it once I multiply it by 4? Because everything is written out. Now you can start to simplify this. What's the 9 times the 8? Wow.
72.
What's a third of 9? 3 times the 4.77, someone with a calculator. 14-point garbage? Rather 3-ish, maybe? Okay? And so my total volume comes out to be approximately, because I have now rounded, about 86.3 something or other. It's said to round to the nearest tenth, so I'm going to leave it at the tenths. So close. So close.
one missing you.
Yeah, they don't leave it naked. So it's got inches, but since it's volume, what kind of inches are they?
Cubic.
Cube inches. Cubic. Okay? So see how I kept my formulas organized, and anytime I needed an extra number, I came over here, used the proper label for it, and found it. Okay? That's going to be massively helpful to you, and some of you are going to ignore it, and your work is going to look like hieroglyphics again. But some people have learned the good way, that by doing the work, they do better. And I recommend you follow their example. Okay? Ones with holes in them are harder. Guess why?
How do you do the time?
Because there's negative space now.
Because there's negative space. There's missing stuff. So you have to figure out what gets taken out where. And that can be hard to do. Okay? And so this one, we don't need to work it all the way through, but I want you to see how would we set this up. I would need to set up volume. Volume is almost always simpler. So if you want to do volume first, you can. And then you would need to set up your surface area. Okay? For volume, what are we finding the volume of? Is it a cube?
Prism.
The prism. The prism. So I need the volume of the prism. Wait a second. Is the whole prism here? No. I have drilled the center out. So I have to take something away. What has been taken out of my prism? The volume of a cylinder. That's it.
Oh.
Volumes are almost always going to be easier. Okay? But don't worry, the math gods know that, so they make the surface area harder. Okay? So let's practice setting up. How would you find the volume of this rectangular prism? The area of the base times the height. And then you would do minus, how would you find the volume of the cylinder? The area of the base times the height. Well, now you have to figure out the different base areas, don't you? Okay? So for the volume of this guy, what shape is the base of my prism? It's the rectangle. Okay? So that's going to be the length times width times the height. What about, what's the area on my cylinder going to be?
Circle.
It's a circle. So that one's going to be pi r squared times your height. Now, since I'm doing a rectangular prism and I'm having to do area anyway, I think I'm going to have the base here be the base that also the base of the cylinder's on. I'm going to do the bottom here, okay? And so this one would be 10 times 14 times the 12. And then what is my radius? 2 squared. And then what's the height of the cylinder? The 12.
Third of the...
No, look at your formula for cylinder.
Oh, never mind.
Okay? The 1/3 is the cones and the pyramids. Okay? And then you would work that out. That's not the hard one. The hard one is the surface areas. So if I'm looking at this guy, and I want to find the surface area, do I need to find the surface of the entire block? No. I want to find the surface area of the prism, but wait. Is there a piece of surface right there? No. There's a hole.
Wait, is there surface in the middle?
It's drilled out. I have literally drilled through the center. There's a big hole here. So, this is going to be more complicated, isn't it? So let's focus on the prism. I need the whole outside surface of the prism, except for what? The two little circles. Okay? Do I want the rest of this base? Yes. So I want the whole surface area, but I don't want two little circles in it. Yes.
When you drill a hole, don't you get like...
We're getting there.
Oh, okay.
Don't get ahead of yourself. Okay? First I have to focus on the prism. For the prism, am I going to do all the outside things? Yes. Am I going to find an area of both bases of the prism? Yes. But am I going to take out two little circles out of that area? Yes. Once I've done that, then I think, okay, now that I've drilled a hole, have I opened up new surface? Yes, I have all the surface here now. Okay? So what shape is that? It's a cylinder. But on the cylinder, I could paint or color or whatever this surface, but do I have ends on my cylinder? No. So I'm going to do the surface area of the cylinder, but no bases. Notice I have not done formulas here. I'm just telling myself what I need.
So wait, would you just like subtract the...
So let's figure it out. So if I'm doing the surface area of a prism, what formula is that? 2 bases plus perimeter times height? Is that my surface area of a prism formula? Yes. Then I need to take away 2 circles. What is the formula for my circle areas? Pi r squared. Then I need this surface area of a cylinder that doesn't have bases. So find your surface area of a cylinder formula. Do I want the 2 B's? No, so what's left?
pH.
Just pH. See how breaking, don't try and bite everything off at once. Do one chunk at a time to help yourself not go crazy. Now we can fill in what goes in here. Okay, how do I get the area of the base of this? Well, isn't it a rectangle length times width?
Yes.
So it'll be 10 times 14, which is 140. Then I need the perimeter of the prism. So the perimeter of this prism is 10 plus 14 plus 10 more plus 14 more, which is 48. So that goes in for that. Now I need the height. What is the height? That is 12. Now I'm switching colors because I'm going to a different thing. Now I need to take out two circles, the 2 pi r squareds. So let's do pi, what is my radius? 2 squared. What's 2 squared? 4. So 2 times the 4 pi. Plus, now I'm doing my cylinder. I need the perimeter of my cylinder. What do we call the perimeter of a cylinder? Circumference, which will be 2 pi r. See how I came off to the side to work this? I'm leaving it out of my main work. Well, 2 times pi times my radius is 2. What does it come out to be? It comes out to be 4 pi. That's the fun random circle where its area has the same number as its circumference, because pi r squared is the same as 2 pi. It's okay. So I'm going to put that in for my perimeter is 4 pi. What is the height of my cylinder? 12. Now all my numbers are in there. And now it could be calculated. Okay? Do you want to finish the calculations or you just want to leave it? You curious? Someone with a 2 times 140 would be 280. 48 times 12 would be 480 plus 96. 480, 576. Minus 8 pi plus 48 pi. So 48 pi minus 8 pi, that gives me 40 pi. And 576 plus 280 is what, 856? Do these combine? No. What's the only thing it needs? Units. And this was surface area, so it'd be inches squared. Okay? Truly, guys, be willing to take it a nibble at a time. If you try and bite off more than you can chew, life's going to suck. Okay? Yes? Yes! There will be composite figures on the quiz. Turn the page. We're not going to work these all the way, but I want you to see the kind of thing that could happen. I'm going to need to do volume, and I'm going to need to do surface area. What shape am I finding the volume of here? Is it the whole wheel of cheese?
No.
No.
It's just a slice.
It's just a piece of cheese. Okay? Now, this piece of cheese came from what shape? A cylinder. Okay? So I'm going to need part of a cylinder. Am I doing the full cylinder? No. How much of the cylinder am I going to do?
That looks like, well, just a slice.
Just a slice of it. How big a slice? 40 degrees out of 360. Which of course simplifies down to 1/9. So I'm just going to need 1/9 of the cylinder.
I know what I
Remember, volume is always the simpler one. Shh. So I need to do 1/9. Well, what's my cylinder formula?
Your cylinder formula is based on height.
Area base times height.
I knew that.
So my volume will be 1/9 of, oh, how do I do the area of this base? It's a circle, so it'd be pi r squared times height. But I know that I've got the 1/9 in front of it to give me just the slice of cheese that I want. And then could you plug in your radius and your height and get it from there? Okay, so we're going to stop there. You know how to plug and crank. Surface area is going to be trickier. Okay? Because when I cut this off, am I still going to have a piece of a cylinder?
Yes.
So look at your cylinder formula for surface area. Do I still have two bases? Yes, but do I have the full two bases?
No.
How much of the two bases do I have?
9.
I have 1/9 of two bases. Do I still have this outside surface? How do you get the outside surface?
It's 1/9 of the
It's pH.
Oh,
But do I have the whole thing?
no, you have 1/9.
I have 1/9 of the pH.
Can you divide the whole thing by 9 and can you find the surface?
Well, no. And I'm about to show you why.
Okay.
Okay? Because when I cut the cheese, did I make any new surfaces? Yes. I have my 1/9 of the outside, and I have my 1/9 of the bases, but now I have also formed, what shape is this?
A rectangle.
A rectangle.
Do we have to take that out as well?
No, this is added on. It's a new surface. Because when you have a big wheel of cheese, are there any rectangles on the big wheel of cheese?
No.
No, but when I cut out my slice, suddenly I have two new surfaces that are showing. What shape are they?
They're rectangular.
They're two rectangles.
So are we not taking them away?
No, they're adding on.
No, they're new.
No, I thought you can see them.
Oh, we can though, that's the thing. We have, okay, Leah,
Sorry.
the only reason we have drawn this outer part is to show you that it's a piece of a cylinder. But the thing we are actually taking the surface area of is this wedge of cheese, which does have those two rectangles showing. Okay? So then you would have to go, okay, I need to do 1/9 of 2b. What is the formula for my bases? It's pi r squared. Okay? And so then I'd have to go, okay, what's my radius? 20. So pi times 20 squared. So what is my base? 400 pi. So it's 1/9 times 2 times 400 pi. I have just parked the b in there. Everything else came down. Now I'm going to come to this outside surface. I've got 1/9. Do I know the perimeter off the top of my head? No, so I'm going to have to figure out perimeter. How do I get perimeter of this circle? 2 pi r. So my perimeter is going to be 2 times pi times the 20, which will be 40 pi. So that's my perimeter. Now I need the height. What is my height? 15. And then I need two rectangles. How do I get the rectangles?
You do that. Just length times.
Length times width?
Yes.
So what is the length of my rectangle?
It is
20. What is the width of my rectangle?
15.
15. Which comes out to be what, 300?
That sounds about right.
15 times 2 is 30 plus another 0?
Yes.
So I can put my rectangles in there. Okay? See how I plugged everything in individually. I did not try to combine anything up front. Don't try and do crap in your head. That's where you lose track. Then you can go in and go, okay, what's 2 times 400? 800. Now we're going across the top of the fraction. So the 800 pi times 1 gives you 800 pi. What's on the bottom of this fraction? 9. Then here, on the top of the fraction, I have 40 times 15. That's what, 600 pi? And on the bottom of this fraction, I have 9. And then here, what's 2 times 300? 600. Then you can combine the fractions. 800 pi plus 600 pi is 1400 pi over 9 plus 600. Does 1400 divide evenly by 3? No?
Actually, I have no idea.
Well, I don't think it does because it ends in a double zero. And 14 doesn't divide by 9. And so in this case, can you simplify it anymore? No. And so what's lacking now? Units. What kind of units for surface area? So units squared.
Lacking so many things.
And now the last one. Oh, look, in this one you just have to find surface area. So, since you don't have to do volume, focus on the shapes of the surfaces. Bunch of rectangles, huh? So let's figure out our rectangles. What's one rectangle that's on the surface here? How about this one on top? It's got that. How many of these blue ones are there going to be on this whole shape? There will be 4. So I need 4 of these rectangles. What is their base?
Yeah.
4x? And their height? Well, follow it around. This one will match this one, will match this one, will match this one. Oh wait, how long is it? 3y. So I have 4 of those. What's another one? Describe me another rectangle that's on this surface. This big old one in the middle? Why don't I do a square in the middle
Oh, that would be so much more.
and 4 little rectangles?
Yes, thank you.
How many of these big pink squares will there be? Just one on the front and one on the back. How do I get the area of this square? How tall is it?
4x.
How wide is it?
4x.
So it's 4x times 4x. What's another rectangle you have here?
The little mini ones that are next to the...
These little mini ones next to the square?
Yeah.
How many of these are there? Well, there's 1, 2, 3,
Holy moly.
4 on the front and 4 on the back. So there will be, no. This is a regular problem. Because you guys are at the end of geometry and so you've done a year of geometry and now 2 years of working with algebra, plus pre-algebra. You are expected to be this comfortable with letters at this point, without the whining. Okay? And so I've got 8 of these. What is their length? What is their height? It's that 4x. Okay? Any other rectangles we have missed? How about these skinny ones here? How many of those will there be? 1, 2, 3, 4, 5, 6, 7, 8? What is their length?
X,
3y.
What is their width?
X.
Really?
3y.
It's 3y. See how it's going along here? That's your 3y distance. And then to get the total surface area, what will you do with all of these? Add them. Okay, we'll see. 4 times 3 is 12 times 4 is what, 48? 2 times 4, 8 times 4 is 32. 8 times 1, 8 times 4, 32. 8 times 1 is 8 times 3, 24. XY. Oh. What things get to combine? Like terms. So the x squareds, that gives me 64x squareds. Oh, these both have xy. How many xy's is that? 72? xy's? Almost there. It's a surface area, so it's going to be in units squared. Did you see that the different problems require different ways of organizing? This one, color was very helpful for me on the surfaces. Okay? On your homework, look at problem 2. What shape is that?
2 different colors. It's overlapping.
It's a bicone. Okay? Shh. I don't have 2 cones to show you, but I have a cone and a pyramid, so just imagine they're both cones. Are either of the bases on the surface?
No.
No. So am I going to have any big B's that I'm going to add in there? No, you're just going to be using your cone formula for surface area for one side and for the other. Okay? So plan it out, think it through carefully.